In this video, we're going to be focusing on what a conjugate is and how we can use it to rationalize fractions. So I want to start by having you multiply this first expression, x plus the square root of 2, and squaring that. So when we are squaring something, we got to remember what that means. So it means to go ahead and multiply it times itself. So we're going to write 5 plus the square root of 2 times another 5 plus the square root of 2. So we're going to go ahead and multiply this out using distribute or FOIL. So as I do that, let's go through our steps here. 5 times 5 is 25. 5 times the square root of 2 is just plus 5 radical 2. And then radical 2 times 5 is positive 5 radical 2. And then radical 2 times radical 2 is radical 4. But we know that we can simplify the square root of 4. The square root of 4 is simply 2. So that saves me a little bit of work there. Now I want to look for my common terms, my like terms. So I see I have a 25 that can be, go ahead and add that to the 2. And that gives me a 27. And then I have the 5 radical 2 plus the other 5 radical 2, and that's going to be 10 radical 2. And that's our final answer for the product of this problem. Okay, let's look at the next problem, number 2. It looks similar. We have 5 plus radical 2, but this time I'm going to multiply it by 5 minus radical 2. So let's go ahead again. Let's use FOIL and distribute through. So 5 times 5 is 25. 5 times radical 2 is negative, so it's negative 5 radical 2. And then positive radical 2 times 5 is positive 5 radical 2. And then radical 2 times negative radical 2 is negative radical 4. So again, I notice that the radical 4 can cancel itself into just a 2. And I see that I have a 25 here, and then 2. But this time it's negative 2. That's a negative 2 because of this minus right here. So I'm going to actually subtract those, and I get 23. Now the negative 5 radical 2 plus 5 radical 2, think of it like this, negative 5 plus 5, that equals 0. So that technically cancels itself completely out. And since it cancels out, all I have then as an answer is just 23. And look how nice that is that when I multiply it up here and I FOILed it times itself, I get this 27 plus 10 radical 2. But when I multiply by the conjugate, which is what we're going to talk about here, these are called conjugate of each other, I get this nice clean, just the 23. And that's going to be important to us because the conjugate then, by understanding this relationship, it's going to help us to rationalize our fractions. So what is the conjugate? So basically, I'm going to take a binomial like here, 5 plus radical 2, and I'm going to rewrite it, but I'm going to make it the opposite sign on the inside. And so here's a conjugate pair that you'd be probably familiar with. If I had x plus 3, then the conjugate to that is going to be x minus 3. Or if I had 6 minus y, then the conjugate to that is going to be 6 plus y. Those are conjugate pairs. So essentially, they are the same numbers. It's a binomial with the same numbers, but they're opposite signs inside. And the important thing to recognize is that when I FOIL the conjugate pair, the middle terms cancel out. And when they cancel, they actually leave us with no radicals. So that's nice for what we need to do. So if I were to ask you down here, what is the conjugate of 3 plus the square root of 7, your answer would just be 3 minus the square root of 7. It's the same numbers, just with the opposite sign. Okay, let's go ahead then and use the conjugate to rationalize some fractions. Issues with my pens rolling around on my desk here. Let me get this all set up better. Okay. So the first example, in order to rationalize and get this to reduce down just like we had up here, we can use the conjugate because it got rid of that radical sign. So we're going to go ahead and do the same thing for number 3. So we're going to multiply by the conjugate of the denominator, 4 plus the square root of 6. But whatever I do to the bottom, I have to do to the top. Now, to simplify that, we're going to go ahead and distribute. On the numerator, the 7 gets distributed. 7 times 4 is 28. And then 7 times radical 6, 7 is an outside number. The 6 is an inside number, so that just becomes plus 7 radical 6. Now, for the denominator, we're going to go ahead and we're going to FOIL this out, multiply this all out. So 4 times 4 is 16. I have my middle terms. I get 4 times radical 6, so plus 4 radical 6. And then I get negative radical 6 times 4, so negative 4 radical 6. And then radical 6 times radical 6, so it's a negative radical 36. But we all agree that the square root of 36 is just 6. So I see that I have the 16 that comes down. The positive 4 radical 6 and the negative 4 radical 6 cancel each other out. And I just have a negative 6 here, so that all equals 10. So my denominator then is just simply 10. So what I would encourage you to do is, if you recognize a pattern as this foils out with the conjugate, you could save yourself a lot of work and not have to write all of these steps in the middle here. Okay, and let's try the last one, number 4. Same thing, we're going to multiply by the conjugate. So the conjugate of 9 plus the square root of 15 is going to be 9 minus the square root of 15. Whatever I do to the bottom, I have to do to the top. So in the numerator, we're going to go ahead and distribute. This time it looks a little bit different than problem number 3 because the radical 3 is on the inside, 9 is on the outside. So it's 9 radical 3 minus, and then the 3 and the 15 are both inside, so it's the square root of 45. We'll come back to that in just a moment. Let's go ahead and take care of the denominator. So hopefully by now we see, so 9 times 9 is 81. But my middle terms cancel, so I'm not even going to take the time to do that step. I'm just going to skip to the end. And I get a negative square root of 225, but the square root of 225 is just 15. So that equals 66. So hopefully you can start to save yourself a little bit of time if you recognize that. Okay, now this problem, this is not my final answer here. There's still some work that can be done. So I noticed that the square root of 45 can still be simplified. So let's go ahead and do that. And we break that down. 45 is 9 times 5, and the square root of 9 is 3. So let me write the first part here. 9 radical 3 minus, so square root of 9 is 3, so it's 3 with a 5 left over on the inside, all over 66. And I can still take this one more step. And this is like when we were doing quadratic formula. We had 2 terms on top and then the term on the bottom. We noticed that these coefficients, the 9 and the 3 and the 66, all have a common factor. They can all be divided by 3. So when we cancel that out, we now have 3 radical 3 minus radical 3 all over 22. And that's the best answer. Oh, I'm sorry. That's supposed to be a 5 there. Radical 5. And that's the best answer for this problem.